Everyone's talking about how AI is replacing software engineers. There's an article doing the rounds right now that makes some really good points about how the real engineering skills remain deeply human. But I think that even this article misses something more fundamental. Most of the conversation about AI and software engineering skips over one thing that determines whether AI-generated code helps you or destroys you. That thing is continuous delivery. And without it, AI-assisted development isn't just risky, it's more like a trap. Hi, and welcome to the Modern Software Engineering channel. I'm Dave Farley. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well. AI makes code generation cheap, but the problem with that is that it was never the code generation part that was expensive. The bottleneck in software was never the typing. It was the understanding, designing, testing, integrating and deploying solutions to real problems, and doing so in sufficient detail for our solutions to be good solutions. AI accelerates the part of software development that wasn't really the problem. This is, and has been for a very long time, a complete misread of why software is difficult to create. Sure, the technicalities of writing code have their complexities, but the real problem is the enormous surface area of the problems that we want to solve with computers. And that doesn't go away or even change when using AI. There's something called Jevons paradox, and AI applies this paradox to code. Jevons paradox says that when something becomes cheaper to produce, we produce more of it, and so the amount that we spend on that thing goes up. AI has lowered the bar on creating code, and these days, however fast you type as a human, an AI will generate code faster than you. So we're generating more code. But more AI generated code means more complexity, more integration points, more maintenance burden, and more behaviors to evaluate. And if we are not very careful, even less time to understand the problem. This is a theory of constraints problem writ large. And all of that without saying anything about the quality of the code that's been produced. This is not a productivity gain, it's a complexity bomb with a delayed fuse. Unless we control it to prevent it, AI tends to make big leaps rather than the easier to control small steps. And that's very dangerous. This is the opposite of what good engineering in general looks like, but certainly good engineering in software. Good engineering is about small, reversible steps. With fast feedback, we make incremental, verifiable, safe progress towards our goal. AI tempts us to skip that discipline and instead makes giant leaps, too often in the wrong direction. Bob Martin said, "The only way to go fast is to go well." This means that speed without discipline, and even worse, without direction, is an illusion. I once worked on a very complicated large-scale integration project. We were making progress, evaluating and arguing technologies, and starting to build and establish an effective development culture in this organization. These teams, though, weren't used to working at this kind of scale. One Friday, my boss and I, who were leading this project, came into work to be told, "Progress is too slow, so we've done a deal with one of the big software consultancies. You'll be getting 200 consultants on Monday." This killed our project and the albeit slow progress that we had been making. 18 months later, after working 60 to 80-hour weeks for many of those months, we had a lot of burnt out people, but no code that even compiled together, let alone worked together. We'd all been extremely busy, but had made no recognizable progress in any meaningful way. This was one of many lessons that taught me that working so that your system always works, as we do in continuous delivery, really matters. It is central to success. But to achieve this, we have to learn about the problem that we're solving, as well as learning about our solution. AI can't judge whether it's doing the right thing on its own. It can't tell if it got to the right answer unless we also give it the context that we can think of, and probably quite a lot of context that we haven't yet thought of. It's exactly this process of discovery, learning enough about the problem that we're trying to solve and what that means in the broad context of the system that we're trying to build, that is at the heart of effective software development. Whether the coding is done by AI or by people. We need to understand things like how many people will use it, what are the security risks, and so on. But also, what does it really mean when somebody says place an order or register a user? AI can assert that code does what the code does, but unless it understands the detail of the problem we're trying to solve, the detail of how it will be used, and the detail of what the risks associated with all of those things are, it has no means of telling whether the code solves the actual problem or not. Without a way to validate all of those things continuously, we're flying blind and at higher speed, and so when the crash happens, it's going to be a bigger one. I'd like to pause there and say thank you to our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Transfig, and Octopus Deploy. Octopus makes it easy to deliver software to Kubernetes, multi-cloud, on-prem infrastructure, and anywhere else. They automate release, deployment, and operations of your software and AI workloads with a tool that can handle continuous delivery at scale. All of these companies, though, offer products and services that are extremely well aligned with the topics and philosophy of software development that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, do click on the links in the description below to check them out. So why is continuous delivery important, and how does it help in an AI world? My favourite definition for continuous delivery is working so that our software is always in a releasable state. That simple sounding sentence, though, carries a lot of weight. To achieve this, we need to work in small steps, and after each small step that we take, we need to evaluate that our software remains releasable. So we need a definition of what releasable means. At its most effective, this takes the form of automated tests, and we need those tests to give us fast, clear feedback on the releasability of our system, fast enough so that we can run them after every change many times per day. We assemble these tests into a deployment pipeline that provides the definitive statement on releasability. If the pipeline passes the change, it's releasable. If any test in the pipeline fails, it's not. So let's look at each of these things in turn in the context of AI. We can't delegate the determination of releasability to an AI, although it can certainly help, but at its core, the AI can't understand the full context of our system. It can't know what we care about that makes our software releasable unless we tell it. Automated testing does double duty here. It forces us to be precise in specifying what it is that we want, and then, because our specification is in the form of a test, it allows us to verify that we got what we wanted. For this, AI code needs to pass the same bar as human code. Your test suite is the arbiter of quality, regardless of who or what wrote the code. Small incremental changes are important to counter AI's tendency towards big leaps. Even if AI generates a large block, your discipline should be to integrate it in small verifiable pieces. This is true for a variety of reasons. Right now, managing the context window in your AI assistant is an important part of being successful with AI programming, because as that context window fills up, the AI will forget things and start to underperform. Working in small, verifiable steps places a natural limit on the size of each change, and so naturally manages the use of the context window better. To be honest though, this is probably an artifact of where we are in the growth curve of AI capability, and I imagine that context windows won't be such a big problem fairly soon. However, this doesn't mean that working in small steps becomes less important. If you have a perfectly formed picture of what you want to achieve with a piece of software before you begin, you're either thinking of something trivially simple or haven't yet thought about it in enough detail to unearth all the complexity yet. We don't know what our users need. We don't know that our ideas will work. We don't know how the world in which our software exists will change. Working to specify with a test what we want, feature by feature, gives us a practical, useful, intellectual tool that forces us to explore all of these problems in more detail. This small discipline automatically gives us more control, so that the AI is less likely to run away from us, doing things that we don't want or don't need. My current approach is to teach my AI assistant how acceptance testing works, and then specify most things at that level, as my preferred style of executable specification. I find that development, when working this way, is significantly faster, making progress in hours that would in the past have taken me days or weeks. but still giving me confidence that my progress is heading in the direction that I want it to. It is this constant, regular sampling of the correctness of our choices and that constant sense of direction that is at the very heart of continuous delivery, and so important in keeping our AI assistants aligned with our own goals for whatever it is that we are building. As I proceed, I think of new things and learn new things about the problem that I'm working on and about the solution that I'm creating alongside my AI assistant. Fast feedback loops are vital to allow me to spot these new learnings and course correct if we're heading off in the wrong direction. We need to know within minutes, not days, if AI-generated code broke something. A continuous delivery pipeline gives exactly that feedback. Working this way makes it easier for the AI to see its own mistakes, as long as we are being clear about the criteria that it can use to judge those things. I've had my own AI assistant remark with seeming surprise that the acceptance test that I defined highlighted a mistake that it had made. Leaving an AI to make all of those decisions for itself is a recipe for disaster, for all but the simplest of tasks. Deployment pipelines work as quality gates. The pipeline doesn't care if a human or an AI wrote the code. Either way, it enforces the same standards. This is enormously powerful. AI assistance without continuous delivery is alluring, but it's a big mistake, even for small projects. My own experience of this has been that if I work without continuous delivery, then I'll tend to specify in broad terms what I want, vibe coding style, and my AI assistant at some point will say, yeah, I've got it, sometimes even before I've finished explaining. It then rushes ahead and codes and confidently tells me that it generated a bunch of tests and that they're all now passing. Sometimes, probably often, I can run the system at this point and it looks plausible. It's often close to what I asked for these days, but it's also nearly always a fairly naive implementation, enough to prototype the idea, but not even close to being production ready, unless production means I'm going to use it on my own on my computer. I don't know about you, but mostly that's not the kind of software that I've been writing for the last few decades. This is an old story. The classic problem of prototypes. You write some sketchy outline to demonstrate an idea, and as soon as somebody sees it, they say, ship it. So this is barely even a starting point. Worse than that, though, is usually the next step. I ask for some additional new feature, and the AI implements it and tells me that 20 tests are now passing. That's weird, I think. It was passing 24 tests before the change. So I start digging in, and it's removed or broken several tests. Tests it wrote itself, but that were there too tightly coupled to the previous solution for it to keep. So they're now too hard to keep working, and it gave up and deleted them instead. This is a common unit test after the code failure mode, human or AI. So we need to teach it TDD. But we also need to teach it to never delete a test without asking me first. Fine if you know that's the fix. A bit of a problem if you assume that vibe coding alone is enough. The other common failure I've seen is that when we find a bug, the AI struggles to diagnose the solution. Coding assistants are getting better at debugging, but I still see this if I don't keep things under control with small steps, making my design modular and my concerns separated. All the tests pass, but I spot a failure. Doesn't communicate with the server in production, or similar. How can that be if all the tests passed? Well, the tests were naive and simplistic. In one case, I had specified some tests that needed some data that was stored in a database. My AI assistant confidently implemented the test, including populating the database. As we iterated over our solution, we added new parameters that were added to the record in the database. But the AI only updated the schema for the test database and did not keep updates to the production database in line. So despite all my tests passing, when I tried the app in production, nothing worked because the schema that the apps assumed didn't match the schema in the production DB anymore. If I'm working as part of a larger development team, the problem gets even more complex because now, as well as needing to keep the history of changes working while I develop new features, I also need to keep my changes working along with everybody else's changes, including changes made by other AIs. If we have a working deployment pipeline though, this gives us a definitive evaluation for releasability. If the tests all pass for release, if any test fails, then we don't. We have a new training course that can help you with all of this, including the specifics of why continuous delivery is so important in AI-assisted development. The course is from Team Topologies pioneer Manuel Pais and will enable software leaders to accelerate their continuous delivery journey towards fast flow organizations and unleash the power of continuous delivery, ensuring revenue growth, faster delivery, and happier teams. So if you're interested in any of that, do check out the links in the description below. The degree to which we care about the releasability of our system is expressed in the thoroughness of our verifications. What seems to me self-evident is that the most efficient way to achieve a good level of verification efficiently is to combine it with how we specify what it is that we want in the first place. If we adopt the discipline of always specifying what we want, along with the criteria that we will use to evaluate that we got it, which is exactly what behavior-driven development does, then we have a self-verifying specification that clearly tells us and the AI what we care about. We can take this as far as we like. We can specify things like, I want to pay by credit card, as well as I want response times in under a millisecond, or I'd like not to lose any money if the system crashes. In this approach, programming with AI becomes an exploration of what it is that we want. AI generates code, but every change goes through the pipeline. Bad code gets caught in minutes. The team can move faster and safer because the safety net is already in place. Continuous delivery is what turns AI from a liability into a genuine accelerator. Aristotle supposedly said quality is not an act, it's a habit. The discipline of continuous delivery is habitual. It's that habit that makes AI-generated code safe to integrate. The story I told you earlier about the AI not updating the production schema for one of my projects is actually also a story about the success of a deployment pipeline, because it was the pipeline that found the problem. I'd started this project fairly simply, getting some foundational pieces in place for my project. In just a couple of hours working on the basics of my system, I'd taught my AI to do proper TDD and acceptance testing, and we were making fast, controlled progress. Perhaps a bit faster than I had expected, if to be honest, at the start of the session anyway. But I was starting to feel a bit guilty because we'd got further than I had imagined without a properly functioning deployment pipeline. My intention had always been to build up a walking skeleton of my system and use that to have something to build my pipeline against. But my app had grown to a bit more than a walking skeleton because of the lure of the ease and speed with which my ATDD approach to development was working. So now I was feeling guilty, and so started working on building out my deployment pipeline. I did this as an exercise to build the pipeline I wanted and simultaneously construct a pipeline skill for my AI assistant. We started work on both. One of my self-imposed rules is to run acceptance tests against a properly deployed production-like version of the system. So we did that, and immediately the test started failing. Result: my AI assistant was very pleased and seemingly quite impressed, or was that just sycophantic? The real skill in software development has always been engineering systems, not writing code. Continuous delivery is the embodiment of that engineering discipline. AI just makes the distinction more obvious. AI doesn't replace the need for software engineering, it exposes teams that were never really doing engineering in the first place. If you don't have continuous delivery in place, AI will make you worse, not better. Continuous delivery is the foundation that makes AI-assisted development actually work. Start there. It's not about whether AI can write code, it's about whether your engineering practices are strong enough to handle code from any source, human or machine, and still deliver working software reliably. Thank you very much for watching, and if you've watched to this point, you're probably enjoying our content. And if you are, why not consider supporting our channel by joining our Patreon community? There's links to that in the description below. And as ever, to our existing Patreon members, thank you all very much indeed for your ongoing support, and see you next time.